All right. So today's topic is ASHRAE Standard 90.1 2022. Our presenter, as I had mentioned, is Dan Honey. He has almost 40 years of experience in the industry, so a wealth of knowledge. Next slide. And he is very involved with ASHRAE. He's been a member since 2009. He is on the Standard 200 2015 methods for testing chilled beams. He is a voting member on that standard. And he is also on the ASHRAE Technical Committee 1.7P, which is ongoing building commissioning committee. He's also a voting member there. And exciting news that we want to announce as of July 1st. Dan was nominated to become a distinguished lecturer and he was accepted. So he is now a distinguished lecturer for ASHRAE. So that's exciting news. And he does have 4 publications in ES magazine so far. We are the system solution provider. We have multiple disciplines. We are shaping the future of HVAC. Told you we were speeding through these. There's our mission for our education. You can go back and read it during the recording. And then we also have newsletters, and then obviously our webinar Wednesdays. So if you're getting our emails, you're getting our newsletter. If you're not and you want to, send me a message. I'll get you added. And Dan does have a whole bunch of AIA accredited presentations. And Dan, with that, I will hand it off to you.
Kelly, thank you so much. And thank all of you for joining us today for today's presentation on ASHRAE Standard 90.1 2022. We have a full agenda today, so full apologies to begin with, because really I'm going to just have time to speak to some of the slides, and I invite you to consider saving the PDF copy of this presentation in the future to examine them more closely, because there's just Standard 90.1 2022 is approaching 500 pages. So hopefully I've pulled some relevant meat off the bones, but there are many avenues and parts of the standard that I have omitted in this presentation because you just don't have the time. Really could easily be a day, if not a week, review to examine it. So we're going to go through the forward purpose and scope, as well as address some of the sections within the standard, and then look at how this standard will impact HVAC systems in the future. First of all, let's begin with the Department of Energy and the Department of Energy's energy savings analysis that it generated. Under federal law, Title III of the Energy Conservation and Production Act, the Department of Energy has to review any consensus-based building energy conservation standards and issue a determination within 12 months of that publication. Consequently, ASHRAE's Standard 90.122 was issued in January of 2023, and on March 6th of 2024, the Federal Register issued the determination that Standard 90.1 will be the energy performing benchmark for future construction, as it has shown and demonstrated that it offers 9.8% more energy efficiency than the previous 2019 standard. So consequently, under that determination, municipalities have up to 2 years to respond and to update their codes to meet the standards. Realistically, it's probably a 1 to 8 year process, and in some municipalities, even longer. Well, how did the DOE issue its determination? Well, first of all, it put all of the addendum generated since the 2019 standard together and reviewed the text and eliminate any non-energy specific text from the addenda so they can do a quantitative review of buildings modified to the energy use addendums. And that was done using energy modeling, Energy Plus software, and to create whole building models for 16 building prototypes in 16 different climate zones throughout the country. Be aware that 90.1 2022 uses ASHRAE Standard 169-2013 as a climate zone basis. In the 169-2020 edition, I'm sorry for the typo, that zone designation for Maricopa County has been changed from Zone 2B to Zone 1B. So I anticipate in the 2025 90.1 issuance that we'll see the climate data now referencing Maricopa County as Zone 1B. The qualitative analysis done by the Department of Energy issued the determination that only 39 of the 89 addendum provided in the 90.1 standard did impact energy, and they ran a quantitative analysis to generate a gross energy savings and net energy review and conclusion. They found as a result that gross energy in buildings were improved, by, gross energy consumption in buildings was reduced significantly, and the new standard offered 9.8% energy efficiency above and beyond 2019, and 14% efficiency if you include renewable energy on site as prescribed in this issuance of 90.1. Some other factors the Department of Energy realized was that site EUIs increased by 3.7 and source EUIs by 10.1. So it's been a very aggressive determination, and it will significantly impact our future building designs. So Standard 90.1, just briefly, what is the timeline and future direction of the standard? The standard was actually originated in 1975 as Standard 90 Optimum Energy Utilization through Technology Standard. In 2021, it was upgraded to redesignated as Standard 90.1 and was issued a 3-year maintenance program agreement. So every 3 years, Standard 90.1 is amended and updated. Be aware that one of the reasons for the aggressive approach to energy savings in building is that ASHRAE has, as stated in their decarbonization goals, the objective to be by 2030, 50% of the 2015 greenhouse gas emissions generated by buildings. And their goal is to be completely net zero by 2050. So this has resulted in an aggressive upgrade of the 90.1 standard to meet these determinations. Consequently, 90.1 2022 is just become something of well, I wouldn't want to say a monster, but it's become very, very impressive. We now are standing at 468 pages, and since this is the first time I've really studied 90.1, I'll have to admit it was really a considerable challenge, because anywhere where you focused in the standard, you find throughout those 500 pages relevant material. So I did my best today to at least bring you some of the salient factors or sections within the standard that will immediately approach our architectural and our HVAC community. So the International Energy and Conservation Council, what is it? Well, first of all, they are the code writers, and the actual IECC, International Energy Conservation Code, was established in 2000 by the International Code Council. And its purpose is to address energy conservation requirements for all aspects of energy uses. And it's important to understand the relationship between IECC and Standard 90.1. In the IECC Code Section 401.2, it identifies that for a building to meet code, it must comply with one of these 3 initiatives. Compliance with ASHRAE Standard 90.1 being one of them. Though there is differences in some categories of language between 90.1 and IECC that generates some confusion during building design development as to which language should be applied, 90.1 or IECC. So anyway, the IECC code editions and versions are updated usually after, well, they are updated 2 years after the Standard 90.1 edition, and they adopt the latest 90.1 edition at that time. So consequently, the new IECC 2024 code will likely adopt 90.1 2022. However, I just checked yesterday, apparently IECC 2024 is still not out for publication, though it proves to be, it should be imminent. Well, we were very fortunate to lean on the resources of our local ASHRAE chapter that has a complete list for all the Arizona municipalities and the version of IECC codes they've been adapted. And I want you to know that the city of Phoenix is currently using IECC 2018, which uses standard 90.116. We anticipate perhaps in the next round that Phoenix might upgrade, but we'll have to see how that develops. So stay close to your municipalities and their code revisions. I do know that the city of Scottsdale has adopted the IECC 2021 code, as well as the town of Cave Creek. So, standard 90.1 2022. Let's look at the language of the standard. In the forward of the general section of the forward, there's new language added that identifies the scope of the standard has been expanded to include sites as well as buildings, enabling regulation of energy use, but not necessarily limited to the building itself. And consequently, they've offered a new section in the standard, a section 10.5, that addresses on-site renewable energy. In the forward as well, it mentions energy credits and how a new section 11 has been added to allow buildings to achieve another 4 to 5% of cost-effective energy savings by expanding the different energy saving measures available compared to the IECC standard. The administration and enforcement shows no visible difference between the 2022 standard and the 2016, but there have been notable changes in building envelopes, lighting and power, mechanical, the performance rating system, section 12, which was previously section 11 in the 2016 standard, etc., etc. So the scope of this standard is really to address minimum energy efficient requirements for the design and construction, as well as for the plan and operation and maintenance of a building. And we're going to look at the expanded language that addresses the operation of buildings. In the scope, a line 5 was added on what the standard provides. It's line 3 that states new systems and equipment specifically identified in this standard that are part of the site, not just building related, are being addressed. And then they changed the language in previous line 4 and now in line 5 to use the term process application, and it speaks to that in the standard. But let's look at administration and enforcement. These are mandatory requirements under general section 4 and 4.1. And the scope still applies to all buildings, new buildings, additions to existing buildings, alterations of existing buildings, replacement of portions of existing buildings, etc., etc. All of those line items are the same as they were in 2016. However, there is a new line in 4.1, that is 4.1.1.6, sites and new site systems and equipment. And it goes on to say that sites with or without contiguous building or buildings and site systems and equipment using or producing energy, such as site lighting, motors for pumps, etc., transportation equipment shall comply with the standard as described in section 4.2 for systems and equipment. 4.1.6 regarding reference standards that were involved in coming up with the 90.1 language are still applicable, and they're to be found in section 13, previously section 12. But wherever there might be differences between the specific standard and standard 90.1, be aware that the provisions of the 90.1 2022 shall prevail and will be applied. There have been no changes to the normative appendices, no changes into the informative appendices, and the reference standard reproduction annex of the administration and enforcement section. So let's look at what forms of compliance are available currently in the new standard to allow buildings to comply with code. Well, first of all, there are two forms of compliance. There's prescriptive and performance. New buildings all have the same mandatory requirements to comply with sections 4.2.2 through 4.2.5, and either the provisions of section 5, 6, 7, 8, 9, etc., in using a prescriptive path, or you can use performance paths as present in section 12, the energy cost budget method, or the normative appendix G, the performance cost index. So new buildings do have mandatory requirements that every building must comply with to comply with code. They have to comply with section 4.2.2 on documentation, 4.2.3 on labeling of material and equipment, inspections, verification, testing, and commissioning. And all of these sections have been somewhat expanded. A prescriptive path, by definition, is a compliance method in the Commercial Building Energy Code that establishes criteria for energy-related characteristics of individual building components. And this is a pathway that allows design teams and owners to achieve the minimum efficiency required to conform to the standard. So it gives, for building envelopes, what the minimum R values for perimeter walls and insulation values, maximum U factors, and solar heat gain coefficients for windows. In heating and ventilating and air conditioning, it gives minimum SEER 2 standards, ISMRE and IPLV ratings for chillers, and it gives minimal lighting requirements as well. And each section has a different diagrammatic conformance path that shows what is required in which order depending on which path the design team moves down. The prescriptive paths are available in each of the sections, but as well as performance paths are available in each of these paths, with the exception of the simplified version of section 6 in the mechanical, have to conform to all the mandatory provisions. So let's look at the compliance paths. A section 11 has been added now that adds additional efficiency requirements on top of the prescriptive paths referenced. A new mandatory section. This section offers 33 energy efficient measures which a design team can choose to satisfy the total required energy requirements for that building. This gives the design team the opportunity to look at a balanced review based on energy modeling capabilities to assess that though they may not be in minimal compliance with some of the product, they might be overperforming in other aspects of the standard, and consequently a value is generated on the composite assembly of all the components and whether or not they meet a target value that would comply to code. So energy credits are a prescriptive requirement in addition to the base energy code requirements that should offer up to another 5% of increased energy cost savings. You could consider it a prescriptive method on steroids. So it gives you a little bit more energy efficiency. The energy cost budget in section 12 is an alternative to the prescriptive provisions of this standard. It is a performance-based approach. It allows for trade-offs of prescriptive measures, providing building performance target is met. Again, it offers at least another 5% total of energy savings, but it does recommend that any modeling software used to make that assessment comply with ASHRAE Standard 209 that lists what that modeling software should conform to. Section 12 has an equation that allows you to see the actual proposed energy cost of the proposed building versus a hypothetical building energy cost budget, which is the cost of a building that is hypothetical, probably designed in accordance with one of the 16 buildings that ASHRAE has designated and has provided a chart for, as revealed here in the table referenced in the it also gives, the slide gives a definition of what the energy credits are, as how they're to be generated from section 11.5.1 and what the additional gross floor area and alterations and how to come up with an adjustable variable depending on the square footage of the building that is undergoing construction, whether new building or whether or not it is a modification to an existing building. The cost method then goes on to address how energy cost budgets are to be found in table 12.5.1 within the standard, and consequently how to assess what the building budget design determination should be in order to incorporate in the evaluation of the section 12 equation. It also covers minimum equipment efficiency language, supply fan energy in certain package equipment, minimum outdoor air ventilation rates, and economizers. Normative Appendix G is an appendix that was really designed for high performance buildings, for buildings that want to go above and beyond the minimum prescriptive methods offered by 90.1, in complying perhaps with USGBC's LEED version 5 requirements or LEED version 4. Normative Appendix G gives the criteria to provide an appropriate, valid assessment of what that added energy efficiency is. Now, the equation has changed, however, from the 2016 issuance, and you'll notice a reference to PRE. While the equation to see whether or not the performance criteria has been met or the targeted criteria is met is actually a renewable energy component. So that is now factored into Normative Appendix G to see if the PCI target is actually achieved and accomplished when that energy is removed in the overall building profile. Be aware that the building performance factor used in the equation as BPF is referenced in the standard 90.1 4.2.1.1 chart. It is still referencing climate zone 2B for Phoenix, Arizona and Maricopa County. That will probably shift to 1B at a future date, and you can see that in some of the building types or facility types, there will be a change to the factor value. Compliance also shows as mandatory that construction details have to conform to the standard. It has to conform to various other supplemental pieces of information and building manuals. There's been no change since 2016 to either of those two or the labeling of material and equipment. Just to give you a visual cue, I have adjusted the font color. Orange to be language changes that were found in 90.1 to previous sections in the 2016 issue. If the font is in blue, that's completely new language. So just be aware of that moving forward. And that is quite relevant because when you move into compliance for inspections, it shows now that there's really quite a robust inspection program listed, looking at inspection of window assemblies, perimeter wall assemblies, continuous air barrier inspections, operable fenestration and door inspections, loading dock weather seals, and other inspections are listed. And there is now language for verification, testing, and commissioning. Commissioning now is part of 90.1. And there are additional requirements within the section inspections for each section, 5, 6, 7, 8, that addresses requisite commissioning procedures to validate the installation and performance of the various building components. There is also an informative Appendix H for additional commissioning guidance. The functional performance testing has now been added to building commissioning as part of the standard, as well as information on building permit application. And then to enhance building commissioning requirements even further, it goes on to say that commissioning activities prior to the building permit issuance shall be completed prior to the issuance of the permit, and that a copy of the commissioning plan shall be submitted to the owner. So these are all considerable additions to the standard that is going to add some real examination of how we approach commissioning in future buildings. It goes on to say that a commissioning provider shall be designated by the owner to manage the commissioning activities. And also phase commissioning requirements shall be incorporated into the construction documents and other prerequisites as outlined in section 4.2.5.2. So let's look at some of these sections and evaluate how 90.1 has impacted section 5 of the building envelope. Well, looking at the schematic, we'll see that all of the compliance paths in building envelopes must conform to the mandatory provisions, whether it's the prescriptive path, the envelope trade-off path, the energy cost budget path, or the Appendix G performance path. So if we look at the compliance paths available, we see that the building envelope must conform to all of those, to the mandatory sections, and the prescriptive path must conform to all the mandatory 5.4 provisions, as well as 5.7, 5.8. And then the performance paths offer additional requirements to comply with that section, including a prescriptive building envelope compliance and building envelope trade-off compliance. So let's look at a simplified, let's look at the building envelope and see which sections are relevant. The building envelope section 5 does not offer language on the simplified building compliance path, as we will see in section 6. It does offer mandatory provisions for insulation, fenestration indoors, and air leakage. Air leakage is significantly addressed in the language from the 2016 standard, has been expanded upon considerably. And there is new language now on whole building leakage. New buildings less than 10,000 square feet or gross condition floor area shall comply with measured air leakage requirements. And new buildings not less than 10,000 square feet shall comply with one of the following. Measured air leakage requirements in conformance to section 5.4.3.1.4, and as well as a continuous air barrier design and installation verification program performed in accordance with section 5.9.1.2. It goes on to say that measured air leakage that exceeds 0.35 CFM per square foot at 0.3 inches of static pressure will undergo a whole building pressurization testing, shall be conducted in accordance with ASTM E3158 and be performed by an independent third party for verification and testing provider. If the building has a leakage rate of 0.35 CFM up to 0.45 CFM, a diagnostic evaluation such as a smoke tracer or infrared imaging shall be conducted while the building is being pressurized. And there's language to be provided as well that addresses how to proceed should once that problem is identified. So in addition to that, visual inspection of the air barrier shall be conducted, and any leaks noted shall be sealed accordingly to reduce the leakage. Where the measured air leakage rate exceeds 0.45 CFM, corrective actions must be made to the envelope. Exterior building envelope also for a conditioned space shall comply with either the non-residential or residential requirements of tables 5.5-0 through 5.5-8. All those tables, of course, are in the standard. There's language that addresses opaque areas, and under the prescriptive path, the minimum R values for insulation and thermal resistance, and the U factors, C factors, and F factors for entire assemblies as defined in normative Appendix A. Fenestration has minimum requirements as well, a minimal U factor, as well as a solar heat gain coefficient, and those values have been potentially amended depending on the building type, as well as language on linear thermal bridges and point thermal bridges in a building. So all of these sections must be met in the prescriptive measures to make sure that minimum requirements are met. The building envelope section also offers a building envelope trade-off compliance path where you can actually assess the overall performance of a system so that the proposed envelope performance factor of the proposed design is less than or equal to the proposed envelope performance factor of the base design. And if it conforms, then each element of the building envelope does not need to comply to the minimum requirements of the prescriptive measure, providing the overall performance factors are met in evaluating the overall assembly. There are trade-offs limited to building permits, as well as an envelope performance factor language that says that it shall be calculated using the procedures of normative Appendix C under the methodology for building envelope trade-off option. So that gives you direction on how to apply the envelope trade-off compliance path. Section 12 on the energy cost budget method offers language to provide this performance path solution. It shows that a building will conform providing the design energy cost is less than or equal to the hypothetical energy cost budget of a hypothetical standard building. And the building envelope then providing the total value can be met in the design energy cost will be acceptable in accordance to code. Be aware that the ECB method building envelope categories are listed in table 12.5.1 for modeling requirements that will allow for the assessment of section 12 to see that the performance cost values are correctly assessed. Other building envelope language that is present in the foreword of the 90.1 standard talks about requirements were added that address the impacts of thermal bridges and building envelopes. A solar reflectance requirement for walls was added for climate zone 0. Specific provisions were added to distinguish roof replacements from other types of alterations. A new reference was added for steel frame walls, added a definition for insulated metal panels, and normative Appendix A was reformatted to clarify the requirements for thermal performance calculations. Section 6, heating, ventilating, and air conditioning. Section 6 schematic is a little different because there is a pathway for small buildings to apply a simplified approach, which means that if a building qualifies, it does not need to meet the section 6.4 mandatory provisions. The mandatory provisions, however, do offer 4 pathways of compliance: a prescriptive path, an alternative compliance path, an energy cost budget path, and again, conformance to Appendix G of performance ratings. So let's look at the standard. Again, the language is very much similar to the other sectional language with regard to what type of buildings need to utilize 90.1 2022, whether it's new construction, additions to existing buildings, alterations to buildings. But again, it references ASHRAE Standard 169 2013 climate zone ratings as opposed to the 2020 revised zone ratings. So that is going to impact eventually some equipment performance, certainly in Maricopa County. So let's look at the compliance paths for mechanical equipment and systems. We're going to cover the general section, section 6.1. We're going to look at the mandatory provisions, and we're going to look at the simplified approach building compliance path. And then, of course, we have language on submittals and minimum equipment efficiency tables provided. So looking at the compliance path, the prescriptive simplified approach building compliance path for HVAC systems. What is it? It is a pathway that can be used if the building is 2 stories or fewer in height, a gross floor area is less than 25,000 square feet, and each HVAC system in the building complies with the requirements listed in section 6.3.2. And that criteria is that the HVAC system must meet all of the following criteria, including there are significant changes to the tables shown from the 2016 standard to the 2022 standard. So in making this assessment, for example, if you want to look at meeting the simplified approach, the equipment must meet the energy efficiency requirement shown in tables 6.8.1 through 6.8.12 or tables 6.8.1 through 4, so etc. Be aware that as of January 1st, 2023, SEER ratings have been upgraded to a SEER 2 rating. And that is going to have an impact on energy performance of units. A SEER 2 rating actually uses a more stringent testing methodology, and manufacturers will be adjusting their efficiency levels in consequence. For example, one of the things that they did was increase the ductwork static pressure of testing these units from, and that will impact SEER levels in the standard. So be aware of that, certainly for future building, that SEER 2 is to be looked at as the relevant application of performance. Line E on 6.3.2 criteria has added language on heating equipment, stating that it shall also comply with section 6.4.1.4. System controls shall not permit reheat or any other form of simultaneous heating and cooling for humidity control, with the exception that humidity control assisted by hot gas reheat or heat from 100% site recovered energy is permitted. System serving spaces that do not require continuous operation with a cooling or heating capacity greater than 7,000 BTUs per hour shall comply with sections 6.4.3, etc. Be aware that in comparison to the 2016 standard, that's over a 50% reduction in the BTU level. So that's considerable. Systems serving residential spaces other than hotel or motel guest rooms shall comply with their own sections. Mandatory provisions. Let's look at equipment efficiencies. All of these are mandatory under the standard. So look at table 6.8.1-1. We just show you quickly the reference to the IEER table that these standards are going to have to be adjusted to comply with SEER and HFPF2 ratings as opposed to SEER ratings and HFPF, so for heating performance. So these input values are now under a more realistic testing condition design in order to make sure that their values more closely represent actual installations. Be aware that in the 2019 90.1 standard, language was added regarding DX DOAS units, 100% outside air units. A new matrix was added. It's called ISMRE, Integrated Seasonal Moisture Removal Efficiency. So a DX-DOAS will have to comply with the minimum ratings for dehumidification. And those values are listed on table 6.8.1-13. So that is certainly the language since 2019, which would imply that the city of Scottsdale that has adopted the IECC 2021 code will need to look at integrated seasonal moisture removal efficiencies for DX-DOAS units that might be applied in their projects, depending on what their authority having jurisdiction says regarding a building's design mechanical system. There's also mandatory language on calculations, controls, and diagnostics for ventilation system controls. There's language on damper leakage, humidification and dehumidification control, freeze protection, and snow ice melting systems. Not that we should probably need that in Phoenix, Arizona so much, but also on ventilation controls for high occupancy areas. There's mandatory language on insulation, duct and plenum installation, piping installation, etc., as well as walk-in coolers, walk-in freezers, refrigerated display cases, liquid-to-liquid heat exchangers, etc. Under the prescriptive section, there's language now on economizers. Each cooling system shall include either an air economizer or fluid economizer, meeting the requirements of the designated sections. Economizers are not required for the following systems. But if you look at the cooling capacity value for economizer usage, it has been reduced from 54,000 BTUs to units that are at 33,000 BTUs or greater. So economizer requirements for smaller units now is embedded in the language. There's also language on high limit shutoff control settings for economizers as well. So I didn't see that that had actually changed from the 2016 standard. There are simultaneous heating and cooling limitation values. There's language that is prescriptive for zone controls, hydronic system controls, dehumidification, and humidification. There is language compliance for air system design and control, addressing fan system power and efficiency, and fan motor selection and fan efficiency for both constant volume and variable air volume fans. There is new prescriptive language on energy recovery units. Spaces other than non-transient dwelling units shall have an energy recovery system where the design supply fan airflow rate exceeds the value shown in tables 6.5.6.1, 0.2-1, and 2-2. So you would have to pay attention to those to see whether or not an HVAC design would fall under the requirement to provide energy recovery. There's now alternative path, compliance path language available for computer rooms. An optional path can be used as defined in the standard under 6.6, and it goes on to say that an HVAC system that only serves the heating, cooling, or ventilating needs of a computer room with IT equipment load greater than 10 kW shall comply with ASHRAE Standard 90.4. All other HVAC sections shall comply with the applicable requirements of section 6.5. But there is now a new alternative performance compliance path for section 6 in mechanical systems, and it's called the Mechanical System Performance Path. It is an optional path for compliance where the following conditions are met. All systems in the building that meet the criteria in section L 1.1.1. L is one of the normative addendums appendices, in one of the normative appendixes within the standard itself. So language to that is provided on how to actually use the mechanical system performance path. All other HVAC systems shall comply with one of the following, as outlined below, in regards to the requirements of section 6.5, as well as systems that serve heating, cooling, or ventilating needs of a computer room as outlined previously. The mechanical system performance path equation is shown below, where the total system performance ratio of the proposed building is less than the total system proposed ratio of a standard reference building divided by the mechanical performance factor as assigned by the table illustrated on the slide per the climate zone. So this is another performance path that can actually take advantage of energy modeling done for buildings that could result in greater efficiency than pure minimum prescriptive language provides for systems. Other items addressed within the standard we just don't have time to review or go into in any detail are as follows. Required condensing boilers for new construction in order to achieve 90% or greater efficiency for large boils of 1 to 10 million BTUs. Established a minimum enthalpy recovery ratio for energy recovery systems and specified operational requirements to ensure proper economized performance. Revised demand control ventilation requirements to be based on climate zone and standard 62.1 airflow requirements. Modified the minimum efficiency requirements for air source heat pumps, and introduced a new metrics of COPHR for units that perform heat recovery during chiller operation. And there's now language for minimum energy efficiency requirements for large diameter ceiling fans. In section 10, under other equipment, there are some other requirements to the standard 90.1 code. There's now new language that addresses compressorized air systems, new language to address whole building energy monitoring. Measurement devices shall be installed at the building site to monitor the energy use of each new building. Monitoring measurement devices shall be installed to monitor the building use of the following types of energy supplied by a utility, energy provider, or plant that is not within the building. There is language to look at natural gas, the different types of fuels available to buildings, such as natural gas, fuel oil, propane, and the medium of heat transfer, whether it be steam, chill water, or hot water. There's a section 10.4.7 on recording and reporting the energy use of each building on the building site, and it shall be recorded at a minimum of every 60 minutes and reported at least hourly, daily, monthly, and annually. So the system shall be capable of to maintain all data collected for a minimum of 36 months. There's new language on renewable energy resources under section 10. Buildings shall be served that are served by renewable energy sources complying with section 10.4. Goes on to say that the building site shall have equipment for on-site renewable energy with a rated capacity of not less than 0.5 watts per square foot or 1.7 BTUs per hour per square foot multiplied by the sum of the gross conditioned floor area for all the floors up to 3 largest floors. There are exceptions as listed here in the slide. So what does all this mean with regard to building designs? And sadly, I just didn't have time to go into the sections on lighting, heating, water services, etc. They have their own sections and they're each evolved and they each have their own compliance, prescriptive and performance pathways. But this added language, this expansion of building requirements to meet code is going to significantly impact our building HVAC systems. The standard is a bold move to meet the MEP 2030 net zero carbon initiatives, and certainly in an attempt to achieve 50% of greenhouse gas emissions in comparison to the 2015 standard by 2030. It raises the energy efficiency levels by another 9.8% over 90.1 2019. It increases minimum prescriptive building and equipment efficiencies while expanding performance-based language for high-performance building designs. It's beginning to bring in ASHRAE Standard 36, which is ASHRAE's approach for coming up with a standard to write building sequences of operation. Veritech is involved with Veritech Controls and Services today, in fact, to see how we might be a resource for Standard 36 sequences into equipment layouts, and that's a project currently under development, so stay tuned for that. But what ASHRAE is looking for is to normalize sequences of operation for buildings so that there is not this vast swing of performance depending on design teams that write those sequences. It's going to address performance validation through testing, verification, and commissioning. So not only that buildings are designed to meet minimum codes during the design and construction phase, but is there verifiability that they're maintaining that performance 3 years, 5 years, 10 years down the road. So with that being said, you can see the steep slope of energy savings compared to buildings that were designed in the mid-1980s. There's been a significant reduction in the amount of energy required to operate a building, and it's going to continue to be reduced even more. So it begs the question, as buildings are becoming more efficient and thermal energy loads are being reduced due to tighter building skins, enhanced glazing, LED lighting, etc., airflows are going to be reduced in order to meet our peak summer design days. Certainly in Maricopa County, where we designed to 115, now 120, perhaps maybe even 122, as the future goes. Well, in the old days, when buildings were leaked significantly, a large amount of airflow was required to maintain the thermal energy load. But it begs the question whether or not our humidity loads can be maintained as buildings become more efficient, airflows are being reduced. And we should ask the question whether or not 55 degrees off of cooling coils for chill water systems or up to 60 degrees off of DX packaged unitary units are sufficient to maintain humidity control in our buildings? And the answer is probably not. And then we can speak to that at a future presentation of what dew point depressions there are available when air is achieving 55 degrees off of a cooling coil. And I think we'll find that a leaving air condition of lower at 52 to 50 degrees might be more appropriate with lower supply air dew point to stabilize humidity infiltration and gain within the buildings with more efficient buildings that are being served by less airflow. So will rethinking HVAC designs be necessary to meet developing IECC codes? And the answer is yes. I think we're going to see some significant reductions. We're going to see two forces that are coming together, a demand and a requirement for more efficient buildings. But we're seeing another development as well for healthier buildings. And the two do not necessarily need to conflict with each other to do that. So with that being said, are there any questions? And thank you very much for joining us for today's presentation.
All right. We do have a question in the chat. Considering a major U.S. political party is looking to strip agencies such as the EPA of their power, if Project 2025 is enacted, how does this affect ASHRAE and the ICC? Do we have any insight on that? Without getting political.
I can't speak to that at all. It is my assessment, and Kelly, I'd welcome your insight. ASHRAE is pushing forward.
Mm-hmm. Yeah.
And writing the 90.1 codes. How the IECC code and the ICC code might be amended or adjusted based on a different administration. How do we predict? How do we know? We don't.
Right. Yeah, it's
All we can do is assume that we are moving in this direction. We have all the evidence to suggest that. We also noticed that during the previous presidential administration, that while they took a more conservative approach with the EPA and whatever, there was never a reduction in initiative in ASHRAE standard writing that I could see, or in IECC code compliance. So I think that that will continue to hold course, and I just think the evidence of climate change is going to force its awareness on us, that we're going to realize that we're going to have to continue to create more efficient buildings and move towards net zero.
yeah, and from the ASHRAE side, you know, we've been hitting it hard. We've been, you know, going at it this whole last year with decarb, and you know, why stop now? Just keep going. That's the direction.
Correct.
All
But
right.
any other questions?
Yes, we did have a couple more come through. Will the possible EPA refrigerant change out delay being requested affect 90.1 2022?
I am not aware that it will, but that's because I'm not aware of it. I do know, I can speak for Daikin, and for their selection of R32 refrigerant. Turns out R32 is more efficient than R410A. So that we're seeing that the refrigerant change out is actually impacting performance for better performance. There are some refrigerants with very low GWP potentials, but their efficiency is not as great. So consequently, you could actually create more greenhouse gas emissions using lower GWP refrigerants because of the lost efficiency over the life of the chiller versus more efficient refrigerants which still comply with the, GWP level of 700, but may not offer somewhere in the realms of 1 to 10. So yes, refrigerants will impact performance, but there's evidence to suggest it depends on the chiller manufacturer and which refrigerant they adopt, whether it's a more efficient or less efficient solution.
All right, thank you. Next question, economizer table indicated greater than 33 MBH for fan coils located outside the building. Is this to say this applies only to package units and split system fan coils are exempt?
I don't have an answer for that.
So it specifically said fan coils located outside the building?
Well,
Sounds like it. We can look into that one, Robert.
yeah.
Might be language. All right. If that's all the questions that have come in so far, if you have any questions, pop them in the chat. Feel free to unmute yourself. Give it a little bit here. See if any more come in. While I'm doing that, I did send out some direct messages to some of you. If I could not find you on the registration list and you were listed in the meeting, I sent you a message asking if you needed a PDH. So just before you sign off, check your chat and see if I was asking you, because if you do need PDH or AA, I want to make sure that I get it to you. And no more questions have come in. Well done, Dan.
Oh, thank you very much. This one has been a bear. And
Yeah.
I don't think I've done it the justice that it deserves. It requires far more expanded time presenting to it. So, but there's only so much you can do in an hour. So
yeah. So with that, if you do want to dive in deeper, Dan can always do more one-on-one lunch and learns to get more deeper into these individual topics in these sections, because as he said, it is a bear. So feel free to reach out to either one of us.
I would welcome from our guests today any specific issues in 90.1 they would like to see addressed that we should be prepared to answer, certainly in relation to the 2022 standards. So please send us your input. I was very arbitrary in covering the topics that I did today.
All right. All right. Excellent intro to 90.1 2022 in the chat. So thank you so much, Dan. Thank you to everybody for joining us. I will send out an email with the recording, with PDH certs, and a link to where you can download the slide deck so you have all the info at your hands. So, Dan, thank you.
All right. Thank you very much. Thank all of you and stay cool.
All right. Have a good day.
Thank you, Dan and Kelly.
Thank you.